Hello everyone, this is Tian. I'm a PhD student from Temple University. In this video, I will introduce our work, Interpretable Representation Learning for Healthcare while capturing disease progression through time. Electronic health records are the richest available resource of information about patients. In EHR, each patient can be viewed as a sequence of records. Each record contains some specific information about one visit. Due to the sequential nature of EHR data, recurrent neural network has become very popular for predictive modeling of EHR. This is a vanilla RNN framework for diagnosis prediction. First, we represent each medical code as a low-dimensional vector, which we call medical code embedding. Then we use the sum of embeddings of medical codes occurring in one visit as visit representation and feed it into the recurrent neural network at each time step. There are two challenges in applying RNN to EHR. First is time irregularity, which means the time between two consecutive visits can vary or not. Second is the interpretability. The model should be able to provide some rationale behind its prediction in order for doctors to trust the model. One approach to provide the model with some degree of interpretability is to use an attention mechanism which calculates weights for different clinical events. In this paper, our motivation is that attention could be time-aware. For example, for a visit occurred long time ago, doctor may put attention to chronic disease since they have long-term effect. However, for a recent visit, doctor may put attention to actual diseases since they have strong short-term effect. Our proposed model is called timeline. First, timeline uses a self-attention mechanism to aggregate context information for every medical code. Then it applies a time decay function for each disease. There are two inputs to the disease function. One is the time interval between this visit and a future visit. Another is the disease itself, since different diseases should have different progression patterns. The visit representation is the weighted sum of context embeddings. We generated two datasets from a large-scale medical claims data source. One dataset only contains inpatient visits. The second is a mixed dataset which contains inpatient visits, outpatient visits, and physician visits. Our task is to predict the primary diagnosis of one inpatient visit. Our model could provide interpretability by analyzing the weights associated with each medical code. Doctors are able to see which codes our model focused on. Here we see many codes have zero weights. Those codes with weight 0 do not contribute to the final prediction since they do not have information flow into the network. Our model is also time-aware. If we change the occurring time of the one visit, we could observe the prediction probability of our model also changes accordingly. If you are interested in our work, please read our paper for more information. Thanks.